Welcome to Brain Vision.
Okay, so for this question, we're dealing with a hot water heating system and a steam heating system. So the question is asking us how many kilograms of steam is required to supply the same amount of heat as 1 kilogram of water in our traditional hot water heating system. So this question is going to be kind of broken into two parts. Well, first, we want to find heat, or the amount of heat due to the hot water system, and then use that value to solve for the amount of kilograms of steam required to match that same heat supply as if you're using just 1 kilogram of water in a traditional hot water supply. So first thing we're going to do is solve for this Q sub W, which is the heat supplied to the house from the hot water system. So since we're not dealing with any phase changes, we're just dealing with hotter water to hot water into your house. We're going to use our traditional Q equals mc delta T, where m is the mass of the water, C is the specific heat of water, and delta T is our temperature change. So that's one equation. Go ahead and talk about the steam equation, and then kind of just plug in the numbers and run it from there. So for this steam system, we are going to have a phase change, right? Because we're having steam to condensed steam to your house. So we're going from steam to condensed steam, which is essentially water, right? So we're going to have two portions of this equation that equal to the Q sub S, so like the heat from the steam system. So the first thing we're going to have is this phase change. So what do we use for that phase change? So we basically use negative M L sub V. Well, L sub V is just the heat of vaporization, and we'll use that value, which is given to you. The reason it's negative is because you have to take heat out of the steam to get condensed steam, which is why it's negative. We're just going to add. So now we're adding a second part to this, because once it's condensed, now it's to get to your house. So there's going to be heat transfer with that. So mc delta T again. So you have these two opposing quantities that will give us the heat in the steam system. So first things first, let's go ahead and solve for Q sub W, because we have everything we need to solve for that. So in the question, it's asking us to compare the quantities of steam and water to get the same amount of heat. And it gives us that we have 1 kilogram of water. So let's plug that in. 1 kilogram of water is what we care about, right? And then specific heat of water is also given to you, which is 4190 joules per kilogram Kelvin. Units are super important. Keep it all straight in your head. So what's our delta T? So we know that the water is delivered to the radiators at 70 Celsius and it leaves at 28. So that temperature change will be 42. Since we're dealing with temperature change here, delta T, the units don't matter. It can be Celsius or Kelvin. So our delta T is just 42, which is 70 minus 28 Kelvin. All we got to do is multiply all this together and we'll get our heat in joules, of course. Q sub W. Multiply it all out and we get 175,980 joules. So that hot water system is bringing in or supplying that much joules of heat to your house if you have a kilogram of water. Okay, so that's kind of one part done. So now we're going to use the fact that we know how much heat the hot water heater manufactures. We're not going to solve for the amount of kilograms that is required in the steam system to supply that same amount of heat. Okay, so we have Q sub S. We want that to equal Q sub W, because that's what the question's telling us. Equals that same value we just came up with, but now we're solving for an unknown M. So go ahead and kind of pre-factor here. So we have M, we can factor out this expression a bit. So we bring out the M, which means we have C delta T, which would be a different value than what we had just now solving for Q sub W. So C delta T minus this heat of evaporation, L sub V. So now what we got to do is isolate M, solve for M, and then we're good to go. So we have M equal to Q sub W. Again, same thing as Q sub S in this scenario. C delta T minus L sub V. We plug in those values, and we'll get our answer. So we have 175, 980, and this is joules. Our answer will be in kilograms, so the units should work out. And then we have specific heat of water still. Steam is just another form of water, as you know. 4190. 4190, again, joules per kilogram Kelvin. Now, what's our delta T in this situation? Let's think about that. So, as we know, water vapor or steam is at 100 Celsius. And in the question, it says it's leaving the radiator at 35 Celsius. So this means we're going to have a negative delta T, right? So our final T, is 35 Celsius, and our starting temperature is 100 Celsius. So this means our delta T is actually going to be negative 65 Kelvin. Okay. Which actually works out in this case because we want a positive mass, right? We don't want a negative mass, so that doesn't make sense. They're subtracting this L sub V, which again is given to you, which is 2.256 times 10 to the 6th joules per kilogram. So as you can see, our units will check out. We will end up in kilograms, so that's fantastic. Big denominator, that's okay. So again, use your calculator, plug and chug your way, and you'll find that the mass of the steam, in order to compare the heats of the two systems to match that 1 kilogram of water, is only 0.0887 kilograms. So you need about 0.089 kilograms of steam to make the same amount of heat as you would with a kilogram of water. That's our answer.